I thought you'd like to see some of the things we've been exploring in creative programming this year. So this shows Sam's Code journal entry for our very first class, or class 0. And instead of asking their names, I asked him to open the Made with Code website and create a 3D bracelet using a simple visual programming tool, which does not require any prior experience with coding. After introducing themselves using the code bracelet, the girls created their first entry. And for every class, they state a problem they're trying to solve, any bugs they find, and solutions they come up with, as well as tips and tricks for future reference. Now, since the computer is just a tool, we don't always sit in front of screens, and we use a lot of design thinking and improv activities as well. As you can see here, we're working on a rosebud thorn activity to find overlaps between programming, creating, and dog training. I tease them that a computer can be a very well-trained dog if you know the right commands. You can also see Emily acting as the output of an improv activity we did to learn about functions. So here's Emily against the slide I showed them to explain what a function is using the metaphor of a pasta machine. Each girl acted as an argument or parameter, and Emily became the output. 20 strands of spaghetti of all different colors, 1 centimeter wide and 1 foot long. Here the girls are opening up an OPC that I rescued from the library and labeling components. However, I did not explain anything to them beforehand. They had to examine parts, figure out which ones were important, and label them as best they could. After that, they watched a video from How Stuff Works that showed and explained all the core components of a PC, and they compared it with their labels, renamed them, and figured out what they had missed. Their original labeling was not too far off and was very creative. And I used this cute bento box from Rails Girls. Next, they compared the core components of a PC to the Raspberry Pi, which is this tiny, awesome $35 computer you can use to control electronics and embed anywhere in the physical world. I asked them to think of any projects they would like to do, and they decided to create a surveillance device to find out who was stealing our candy at the collaboratory. So these are the steps we followed for this project, and it was entirely up to them to figure out what to do. I had no idea what they would choose, and they had never worked a Raspberry Pi before. So they had to research similar solutions, adapt them, and learn how to install and test the hardware and software. And last but not least, they had to teach each other. So this is the Pi camera team working in pair programming mode as pilot and co-pilot, getting the camera to work for the first time. Here you see another pair testing the infrared sensor, and after each team mastered their specific component, they had to teach each other and implement the full candy camera solution. So one of the wonderful things I find about working on real-world problems is that they truly prepare, empower, and inspire the girls. When the sensor team was looking at the code, they found at the Raspberry Pi Learning Resources, they found a bug. And the sensor was not working, and they realized that there was a problem with a variable. So I tweeted the problem, and Raspberry Pi team immediately tweeted us back. They asked us to fix the code, making a Git pull request, but since we didn't have class until the next day, when they came to class, they realized that the code had been fixed because the team opened it up to teach the other group of girls. And they realized the bug had been fixed. So I showed them what had happened on Twitter, and they felt very, very empowered. They literally said, wow, we have power. But they also saw that bugs happen even to very experienced programmers, so it was a great growth mindset experience.
People watching to
watch them be like standing behind us, like watching us.
Yeah, watching them. Wait, they took the camera.
They got one.
Who is that?
So here you see the girls at their moment of discovery when they finally had a chance to go through all the files once they left the surveillance device or candy cam running for about a week. And as you can see, they found several candy thieves. There were more. And but also the hard drive on the Raspberry Pi filled up because they didn't realize this could happen, leaving it running so long. And I didn't warn them about the problem because this way it created a teachable moment, and they had to figure out how to delete the files using Linux commands because the graphical user interface did not open. So this is a great way for them to develop critical thinking skills and really develop persistence. So thank you so much for watching.